Welcome to this new video. We shall discuss organic chemistry. This will be the second series, the second video on organic chemistry. The second video on organic chemistry. In this video, we shall discuss homologous series. Homologous series. We shall discuss hydrocarbon radicals. Hydrocarbon radicals. We shall discuss functional group. Functional group. And we shall look at isomerism. 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 This is everything we are going to discuss in this video. We shall look at homologous series. Under the homologous series, we shall look at the meaning of homologous series, the characteristics of homologous series. After that, under the homologous series, we shall look at the root words of organic compound. The root words, how you can get the name of organic compound. After that, we go to what? Hydrocarbon radicals. We go to what? Functional group. Then we go to what? Isomerism. Let me write them here so that I'll be taking them one after the other. I said the first one is homologous series. Homologous series. The second one is what? Hydrocarbon radicals. Hydrocarbon radicals. Hydrocarbon radicals. The third one is functional group, FG, functional group. While the last one is what? Isomerism. Isomerism. Let us take them one after the other. Let us take the first one, homologous series. Homologous series. What is a homologous series? What is a homologous series? Just know that homologous series is a series that follows a regular pattern in which each successive member of a family differs by molecular formula of CH2, which is also known as what? Methylene. Methylene. Take note of that. I said this is a pattern that follows a regular this is a series rather that follows a regular pattern in which each successive member of a family differs by what? Molecular formula of what? CH2. This molecular formula is known as what? Methylene, which is also known as what? Molecular weight or molecular mass of what? Of 14 gram per mole. I will explain that. Let me quickly write the meaning of homologous series. Homologous series. Homologous series. Homologous series. I say this is a series. Homologous series. This is a series that follows a pattern, a regular pattern. It's a regular pattern. A regular pattern in which each successive member of a family differs with molecular formula of CH2. This molecular formula of CH2 is also known as what? Methylene. Methylene. And you can also know homologous series in this form because there's a question that came out, maybe NECO or WAEC. The question was asked, What is the molecular mass difference of each member, each successive member in a homologous series? What do they mean? Look at carbon. The mass number of carbon is 12. Hydrogen, mass number of hydrogen is what? 1. Then if you find the molecular mass of this what? Of this CH2, of this methylene, if you find the molecular mass of this methylene, that means we have molecular mass of methylene. Carbon is what? 12 plus hydrogen is what? 1. How many hydrogen do I have? 2 plus 1, that means 1 times 2, which will give you 2. Then you have 12 plus what? 2, which is what? 14. That means each member of a homologous series, each member of a homologous series differs by what? Molecular weight or molecular mass of 14 gram per mole. Each member of a homologous series, each successive member, let me put it like that, each successive member of a homologous series differs by molecular weight or molecular mass of what? 14 gram per mole, which is the same thing as what? Methylene, that is CH2. Take note of that, CH2. This is homologous series. And homologous series, you can also give another definition to homologous series. It's a series that follows a regular pattern in which each successive member of a family have the same chemical properties, different what? Physical properties, the same general formula. I can take that as what? Characteristics of homologous series. Let us go. Characteristics of homologous series. Characteristics of homologous series. Characteristic of homologous series. Characteristics of homologous series. Number 1, characteristics of homologous series. Each successive member of a family, they have the same general formula. The same general formula. For example, what are homologous series in organic chemistry? We have alkane, it's an homologous series. Alkene is an homologous series. Alkyne is an homologous series. These are hydrocarbon compounds. Don't forget. These are hydrocarbon compounds. They are homologous series. They exhibit what? Homologous series. We have alkanol. Alkanol is a derivative of the hydrocarbon compound. It exhibits homologous series. Alkanoic acid. This is also an homologous series. This homologous series, any member in each of these series, in each of these homologous series, they have general formula, which I will still explain. But first of all, let us look at characteristic of homologous series. They have the same general formula. That means all the member of a homologous series have the same word general formula. Number 2, all the member of a homologous series, all member of a family, they have the same chemical properties. They have the same chemical properties. Number 3, in a homologous series, all the member of a homologous series, they have the same method of preparation. The same method of preparation. Number 4, they have different physical property. They have different physical properties. These are characteristics of homologous series. Homologous series is a series that follows a regular pattern. Each successive member of a family, differ by molecular formula CH2. CH2 is known as what? Methylene, or differs by molecular mass. The molecular mass of methylene is what? 14 gram per mole, because carbon is 12, hydrogen is 1, and we have 2 of hydrogen. 1 times 2, 2. 2 plus 12, that is 14. Homologous series, each member of an homologous series differ with molecular mass of 14 gram per mole, which is methylene. Then these are the characteristics of homologous series. Characteristics of homologous series: all successive member in a family, in an homologous series means family. It means what? Family. All the successive member in a family, that means in a homologous series, they have the same general formula, the same chemical properties, the same method of preparation, different physical properties. Different physical property. Then let us look at the root word, how you can get names of what? Homologous series and all the member in there. Let us look at the root words. Let us look at that. Let's look at that. We have the root words. Root words of hydrocarbon compound and its derivative. The root words of hydrocarbon compound and its what? Derivative. When you have one carbon, the root word for one carbon is what? Meth. Meth. 2 carbon, the root word is what? Eth. 3 carbon, the root word is what? Pro. 4 carbon, the root word is what? But. 5 carbon, pent. 6 carbon, X. 7 carbon, ect. 8 carbon, oct. 9 carbon, non. 10 carbon, we have dec. 10 carbon, we have dec. We have 11 carbon, let me give you up to 20. We have undec. 12 carbon, we have do. Do-dec. 13, don't forget, 3 means what? Tri. 4 means what? Tetra. Take note of that because you know this. Then 13 will work because we have 3. Then dec is what? 10. 3 is tri. Dec is what? 10. 3 is tri. 10 is what? Dec. Then 10 plus 3 is what? 13. We have tri-dec. 14. 4 is what? Tetra. 10 is what? Dec. Then 10 plus 4 is 14. That means 4 means tri. Tetra rather. Tetra. 4 tetra, 10 dec. Then when you have 10 plus 4, that is 14. 4 means tetra. That means tetra dec. 15 pent. 5 means what? Pent. Then plus 10. Pent dec. 16. 6 is what? X. That means X dec. 17. 7 is what? X. That means X. I'm sorry, X. 17 is what? X dec. 18. Oct dec. 19. Non dec. Then 20 is icosane. Let me stop here. 20 is what? Icosane. Please pause the video and quickly write it out because I will use it to teach you how you can get names of homologous series. Write it down, pause it. You can pause the video and write it down. But what you are required to know is from 1 to 10. That is what I will use. 1 to 10 carbon. 1 to 10 carbon. Then I will now still use it to explain homologous series better before we go toward functional group. Then we move toward isomer merism. You can pause the video and quickly look at this. Quickly write 1 to 10 or 1 to 20, but we are taking what 1 to 10. Please quickly write them out, please. Then let's continue. Let's continue. Let's continue the root word. Let's continue. Let's continue. When you have, I said one carbon is what? Met. 2 carbon, et. 3 carbon, pro. 4 carbon, boot. 5 carbons, et. 6 carbons, et. 6 carbon s, 7 carbons, et. 8 carbons, ot. 9 carbons, non. 10 carbon, dead. This is what I need. Then let's take each homologous series. The first homologous series is alkane. Please, I want you to listen carefully because this is where you need. If you want to understand hydrocarbon and its derivative, which is what the study of, which is what organic chemistry, the study of hydrocarbons and its derivative, which is organic chemistry. This is where it starts. Please take note. Follow. Listen. This is alkane. Can you see ANE? This ANE is the family name. The surname, as you have your own surname. The family name, ANE. Look at this one. This is another homologous series. Can you see? They have the same ALK. This is common name. This is the family name of this one. Look at this. This is the family name of this one. That means ANE is the family name of this homologous series, of this family. This is a family. Homologous series is family. Then the family name is what? ANE. This is homologous series family. The family name is ANE. Please take note. Let us move, please. If one carbon fall on this family, one carbon is on this family, and the root word of one carbon is what? Met. Then I now have one carbon in this family. One carbon in this family. That means the root word is what? Met. Then you now add the surname, which is ANE, which is methane. That means this ANE shows that this one carbon belongs to this one family. This ANE shows that this one carbon belongs to this family, which is what? Alkane. Belongs to homologous series of what? Alkane. This question came out 1981. That methane belongs to which of the following what? Family? 1981, number 4. The answer is what? Alkane. One carbon. Met, that is the root word. Then if that one carbon is under alkane, just add ANE, that is methane. Number 2, when you have 2 carbon, and you know that the root word of 2 carbon is et, that means et. Then that et belongs to what? Alkane. That root carbon, 2 carbon can be found under alkane. Just add AE, ethane. When you have 3 carbon, and you know the root word of 3 carbon is what? Pro. Then that 3 carbon, if it belongs to what? Alkane, just write pro, then add ANE, propane. This shows that 3 carbon belongs to this family because it carries their surname. When you have 4 carbon that belongs to alkane, that means what? Butane. 5 carbon, the root word, pent, then belongs to alkane, ANE, pentane. 6 carbon, X, that means, then you can practice 7 carbon, 8 carbon, 9 carbon, 10 carbon. You can pause the video and write the family name. Pause the video and write the family name. Pause the video, write the family name. Let's look at the answer. 7 carbon will be what? Heptane. 8 carbon will be what? Octane. 9 carbon will be what? Nonane. 10 carbon will be what? Decane. Then 1 carbon now say undecane. Do decane. Try decane. But we just name 1 to 10. Let me take another homologous series. When you have alkene, that's the surname Ene for this one. Ene for this one. Ene for this one. That is the surname Ene. And this family and this one, these two family, this one alkyne, Yne and Ene, they don't have 1 carbon. They don't start with 1 carbon. Why? Because they are unsaturated hydrocarbon. This one is known as saturated. When we get to the family, I will let you know. Alkane is known as saturated hydrocarbon. It exhibits sigma bond electron. That means single bond between its carbon atom. Single bond between its carbon atom. It is saturated. While these two, they are unsaturated. Their number 1 member start with 2 carbon. Their first member for alkene and alkyne start with 2 carbon. Then let's move. Under alkene, 2 carbon. It start with 2 carbon. And 2 carbon, the root word is what? Earth. Therefore, this one is earth. Then add the surname Ene, 18. Ene. 3 carbon is what? Probe. Put it there. Probe. Then what's the surname? Ene. Propene. 4 carbon. Boot. Add the surname Ene. Butene. 5 carbon is what? Pent. But it is under alkene. Add the surname pentene. Then you can do the rest. Then let us go to homologous series better. Because I told you characteristic of homologous series. That question came out in WAEC. WAEC say give 4 characteristics of homologous series. Give 4 characteristics of homologous series. I've given it to you. They have the same general formula, the same method of preparation, the same chemical properties, different physical properties. Let us look if all these they have the same general formula, and if they really differ by what? CH2. Let's see if they really differ by what? CH2. Let's move. Hope that you understood this. If it is under alkyne too, let me pick alkyne. Let me say alkyne. This is another homologous series. Alkyne, Yne. That is the surname. I told you this one and this one start with 2 carbon. That means 2 carbon under this one. Just take ETH, then put Yne, ethyne. 3 carbon under this. Just put probe. Then put Yne, propyne. 4 carbon. That means 4 carbon is boot. But it is under this family. The surname is Yne, butane. Then you can try the rest. Then let's move further to homologous series. Let me explain so that we can move to the next one, which is hydrocarbon radical. Hydrocarbon radicals. Then we move to functional group. Then we talk more on isomerism. Even I can even do isomerism as a video. I can do isomerism as a video. Okay, let's move. Look at alkane now. Alkane. This alkane is saturated hydrocarbon. Saturated. It is known as saturated hydrocarbon. This is the surname. Surname can also be called suffix. The surname ANE. This ANE is called suffix. That's the surname. But to me, for better explanation, I like calling it what? Surname. ANE, which is the suffix. ANE, the last name. Last name. That means so means what? The last name. Suffix. That means I like calling it surname. A-N-E. Then let's move. Then I know that this alkane, this alkane has a general formula of CnH2n plus 2. It has a general formula. Please take note of that formula. There's a question that came out in JAM. It says homologous series with a suffix of ANE and homologous series with a suffix of NNE has which of the following general formula? A. They put CnH2n plus 1. B. CnH2n plus 2. C. CnH2n minus 2. D. CnH2n. A homologous series with suffix of ANE has a general formula of what? CnH2n plus what? 2. That means alkane family, alkane homologous what? Series. Let's move. One love, one heart, let's get together and feel alright. Then look at this. I told you the first member on this is when you have one carbon. And N means number of carbon. N means what? Number of carbon. Take note. N means number of carbon. Number of what? Carbon. Take note of that. Number of carbon. N means number of carbon. When for you to get one carbon, that means N is 1. When you have N to be 1, using this general formula, we have C. Anywhere I see N, I put 1. H, 2 times 1, 2 plus 2, 4. Then since this one is 1, there is no need to write this 1. That means C1 means C. Therefore, what is the name of one carbon? Can you see one carbon is what? Met. Then it is under alkane, methane. That means the formula for methane is 1CH4. When N equal to what? 2. That means second carbon. What we are? Change N to 2. C2H. Anywhere you see N, change it to 2. Then 2 times 2, 4. Plus 2, 6. That means what? 2 carbon. Can you see 2 carbon? X. Because it is under alkane, surname, suffix ANE, methane. When N equal to what? 3. You have C3H. That means change 2 times 3, 6 plus 2, 8, which is what? Propane. N equal to 4, you have C4H10, which is what? Butane. N equal to what? 5 carbon. That means change N to 5, C5H. 2 times 5, 10 plus 2, 12, which is what? Pentane. Then what is homologous series? Go back to the definition of homologous series. It says that this is a series that follows a regular pattern in which each successive member of a family, this is a family, alkane, each successive member of a homologous series of a family differs by molecular formula of what? CH2, methylene. Differs by what? Methylene. Differs by what? Methylene. Differs by what? Methylene. Then let's look at this. This is the family alkane. This is the first member. This is what? Successive member. Look at this. The difference between the first member and the second member. C2 minus C1 will give you what? C. H6 minus H4 will give you what? H2. Look at this one. The successive member of the what? Second member is what? The third member. C3 minus C2 will give you what? C. H8 minus H6 will give you what? H2. Look at the difference between this. C4 minus C3 is what? C. H10 minus H8 will give you H2. That is homologous series. Each successive member of this alkane differ by what? Methylene, which is what? CH2. And CH2 is what? Molecular mass of what? 14 grandpa, move. Take note of that. If I don't want, can you see they have the same general formula? The same general formula. That means characteristic of homologous series. They have the same general formula. If I don't want to use this general formula for me to get the next member after pentane, what will I do? I'll just add CH2 to this one. Add this CH2 to pentane, I will get the next one. Add CH2 to that one, you will get the next one. Let's see. Just add CH2 to this. That means C5 plus C1 will give you what? C6. H12 plus H2 will give you what? H14. And 6 carbon is what? Z. If I use the, when N cut was 6, if I use the same formula, I will get the same thing. That means use the formula. C, N is what? 6. H, 2 times 6, 12 plus 2, 14. That is homologous series. That is homologous series. You can try that for alkene. You can try that for alkyne. You can try that for their derivative also. You will get the same thing. I could see some people in their mind, they will say, okay, do first 3 of alkene. Do first 3 of alkene. Okay, let me do first 3 of alkene. For alkene, this one is unsaturated hydrocarbon. Unsaturated. Why is it unsaturated? Double bond between its carbon-carbon compound. Take note, this one, this alkene has general formula of CnH2n. Alkane is CnH2n plus 2. This is the second homologous series of hydrocarbon compound. The second homologous series of hydrocarbon compound, alkene, it is unsaturated, double bond. That means when you remember the first one, CnH2n plus 2, this is alkane. Just remove the 2 for alkane. Remove the 2. That is that. Then let's see. I told you this one, the first member start with when n equal to 2. That means I'll see 2, H, 2 times 2, 4. 2 carbon, 8. But it's under ENE, put 18. When n equal to 3, change the 3, H, 2 times 3, 6, which is what? Pro. 3 carbon, pro. Then under propene. When n equal to what? 4, that means we have C4, 2 times 4, 8. 4 carbon, but. That means butene. And take note, I told you that they form homologous series. Look at the difference between these two. C3 minus C2 will give you C. A6 minus H4 will give you H2. C4 minus C3 will give you 6. H8 minus H6 will give you what? H2. Take note of that. Let us move to the second thing for today. Hydrocarbon radicals. Hydrocarbon radicals. Hydrocarbon radicals. Hydrocarbon radicals. What are hydrocarbon? Hydrocarbon is a compound that contains hydrogen and what? Carbon. Hydrogen and what? Carbon. And when you have hydrocarbon radicals, hydrocarbon we have alkane is an hydrocarbon. Alkene is an hydrocarbon. Alkyne is an hydrocarbon. Even aromatic benzene is an hydrocarbon. Benzene is an hydrocarbon. Let's look at that. What is alkane? We have alkane, we have alkane radicals. This is hydrocarbon. Hydrocarbons. Then we have hydrocarbon radicals here. Hydrocarbon radicals. Hydrocarbon radicals. The hydrocarbon radicals of alkane is what? Alkyl. Alkyl. The radicals, the radicals carry YL. The radicals, hydrocarbon radicals carry what? YL. 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 Take note. The hydrocarbon radical of alkane is what? Alkyl. Alkyl. And how do we have this alkyl? How do we have hydrocarbon radical at the first place? When hydrocarbon compound loses one atom of hydrogen. you have hydrocarbon radicals. When hydrocarbon compound loses one atom of hydrogen, you have hydrocarbon radical. For example, when alkane loses one atom of hydrogen, you have alkyl. The symbol for alkyl is what? R, which is hydrocarbon radical. Alkyl is formed when alkane loses one atom of what? Hydrogen. And there's a question that came out in JAMB. What is the general formula for alkyl? Take note. We have alkane. The general formula for alkane is CnH2n plus 2. When this alkane loses one atom of hydrogen, what will you have? You have CnH2n plus 1. That means that plus 2 because it lost one hydrogen plus 1. For example, you know methane is CH4. When methane now loses one atom of hydrogen, what will you have? CH3. CH3. This is what? This is methane. Methane. Let me rub this one because I'm still coming. This is methane. Let me write it properly. This is CH4, which is what? Methane. Then when it loses one atom of hydrogen, example of now CH3, which is change this I'm sorry that ANE, can you see ANE has been changed to what? YL. Change this ANE to what? YL. That means we have methyl. ANE change to YL. ANE change to YL. Methyl. The next one, when you have C2H6, which is ethane. When it loses one atom of what? Hydrogen, what we have? You have C2H5. Change ANE, you have ethyl. This ETC, when you have the next one, H8, which is for propane. Change it, you have C3H7, which is for propyl. These are what? The hydrocarbon radicals of alkane. Hydrocarbon radicals of alkane is alkyl. When alkane loses one atom of hydrogen, the symbol is what? R. The general formula is what? CnH2n plus 1 of alkyl. Take note of that. Let us go to the next one, which is what? You can write it down. The next one, the next family, alkene. What is the hydrocarbon radical of alkene? Hydrocarbon radicals of alkene. The same thing. When alkene loses one atom of hydrogen, you have its radical. When I told you, when hydrocarbon compounds lose one atom of hydrogen, you have hydrocarbon radicals. When this one loses one atom of hydrogen, you have change only this one, E, only the last E will be changed. You have ALKEYL. This is hydrocarbon radical of alkene. Just change the last E. For example, this one, general formula, CnH2n. H2n. Then what will be the general formula of this one? CnH2n minus 1. Look at it. What is the first member of this? What is the first member? We have C2H4, which is ethene. When this ethene loses one atom of hydrogen, what we have? C2H3. C2H3, which is what? Ethylene. Take note. That is when this one loses one atom of hydrogen. Take note. We have alkene, ethylene, ethylene. Take note of that. But in JAMB, they only talk on this. Take note. But know the meaning of hydrocarbon radicals. Just know it when you move toward 100 level. Let me quickly give you the next one before we go to functional group. That's where the work is. functional group. When you have the next one, you have alkyne. The hydrocarbon radicals of alkyne will what? Just change this E to YL. That means ALKYNYL. Take note of that. Change this. Take note. The hydrocarbon radical of benzene is phenyl. Take note. It's an hydrocarbon radical. It's an hydrocarbon radical. When that means C6H5, it's an hydrocarbon radical. Let us move to functional group. Then before we move to isomerism. Isomerism, I will take that as a video, separate video. I will make it as a separate video, but it won't be more than 30 minutes. I'll make it as a separate video. Next move. Functional group. What is a functional group? Is there in JAM? Which of the following terms determines the chemical properties of organic compound? Option A, isomerism. Option B, metamerism. Option C, halogenation. Option D, functional group. The answer is what? Functional group. That's just simple definition of functional group. It determines the properties of organic compounds. That means chemical properties of organic compound. Take note. Right. Hydrocarbon compound. This is a group of atoms or radicals. The group of atoms or radicals that determines the chemical properties. That determines the chemical properties, and it can also determine general properties of organic compound. It can also determine general properties, can also determine physical properties. That's why sometimes in the JAM question they put determine chemical property. But it could be given as what? The group of radicals or atoms that determine the properties of organic compound. Write it down. This is the group of atoms or radicals that determine this is a group of atoms or radical that determines the property, which could be physical or chemical properties, and mostly chemical properties. that determines the properties of organic compound. It determines the chemical properties. It could be physical properties, but mostly chemical properties of organic compound. Take note. Take note that. That is functional group. Then let us look at each homologous series of hydrocarbon and their derivative. Let us look at their functional group, the name of their functional group, and the structure of their functional group. The name of their functional group and the structure of their functional group. The name of their functional group and the structure. Because if you come out in UTME, in WAHEC, in NECO, they say which of the following is the structure of functional group of carboxylic acid, the structure of functional group of alkanoates, the structure of functional group of what? Of alkana, which is aldehyde. What is the name of what? The functional group of what? Of carboxylic acid. You have to know the name, carboxy. You have to know the name, carboxy. Let's look at that, class. One love, one heart, let's get together and feel alright. I hear the children crying, one love. Hear the children crying, one heart. Give thanks and praise to the Lord. Homologous series. We have name of the homologous series, and we have structure of the homologous series. We have homologous series, name of the word homologous series, name of the functional group, rather, name of functional group, then structure of functional group. And I don't need to give you the general formula, because we still talk on them one after the other. The first one, you have number one, alkane. Alkane is a single bond between this carbon-carbon atom. The name single bond. That is this. Number two, we have alkene, another homologous series. That means homologous series means family, another family. The name of the functional group, double bond. That means we have number three, alkene. Alkene. The name, triple bond, which is triple bond, which is that. We have alloalkane. That means alkyl halide. We have alloalkane, number four. We have alloalkane, which is also known as alkyl halide. The name of the functional group is halogen. The symbol is X. And X means the halogen family, which are what? Fluorine, bromine, chlorine, bromine, iodine. We have astatine, we have tennessine. Take note. X means what? That's the structure of their what? The alloalkane. They are what? Alkyl halide. The name of their functional group is what? Halogen. The symbol is what? S. And S could be any one of these. The S could be what? Any one of these. Let's move to the word. The next one, we have the alkanol. Number five, alkanol. Another name for alkanol is for alcohol. This one we have paraffin, olefin, acetylene. But we are still going to take them one after the other. Paraffin, olefin, acetylene. This one we have alcohol. That's what common name, alcohol. The name of the functional group is what? Hydroxy. That means the structure OH, OH, OH. Number 6, we have alkyl. Another name for alkyl, we are still going to take them aldehyde. Aldehyde. The name of the functional group is what? Aldehydic functional group. The structure is CH, which is also what? CHO. This is the structure. Take note. The structure. Sometimes it can be given like as this. It can be given like this or like this. It's the same. It can be given like this, double bond. The bond between the carbon and the oxygen is what? Double bond. Or it can be given in this form. It can be given in this form. Take note. Take note of that. Take note of that. The next one, we have number 7. Number 7, we have alkanol. Alkanol, which is known as what? Ketone. The common name, ketone. The name of the functional group is ketonic. Ketonic or ketone. Just remove this H. That means you have C. You have this. You have this. You have this. That means CO. CO. Please quickly pause it and write. Quickly pause and write. Quickly pause and write. Quickly pause and write. Okay, let's move. We have carboxylic acid, which is known as carboxy. We have alkanoate. Another name for alkanoate is what? Ester. 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 Another name for alkanoate is ester. Okay, let's move. Let's move. Let's move. Buffalo soldiers, sing a rasta. He was a buffalo soldiers in the heart of America. Next one. Number 8. We have alkanoate. Alkanoic acid. Let me take alkanoic acid, which is what? Carboxylic acid. Carboxylic. The name of the functional group is carboxyl, which is what? COOH, which can be drawn. This one always come out in jam. Take note. Double bond, then OH. You can write it like this, draw it like this. Take note. One of the oxygen is what? The bond between one of the oxygen and what? And carbon is double bond. Then the one that has what? Single bond, the oxygen that has single bond between it and carbon, hydrogen is attached to that. Take note. Take note. This is it. This is it. Take note of that. Please take note of that. Then we have the next one. We have the next one. The structure is this COOH. The next one, number 9, we have alkanoate. Alkanoate, which is what? Ester. The functional group name is also ester. That means COOR. This one is what? Alkyl group. COOR, which can be drawn like this. COOR. Take note. Take note. Take note. Take note of that. The next one is what? Ether alkoxyalkane. Ether alkoxyalkane. 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 Number 10, alkoxyalkane. Another name for it is ether. 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 This one is ester. 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 It is formed by esterification reaction. That means reaction between, this one is formed by esterification reaction. Reaction between alkanoic acid and alkanol. This one is ether. Ether. hectare. Take note of that. We are going to take them after in the fourth series. In the fourth series, that means fourth video, we are going to take each homologous series. This one, the name is for divergent or divalent oxygen. Divalent oxygen. Divalent oxygen. Divalent oxygen. That means divalent oxygen. Please quickly pause and write before you move. Quickly pause and write before we move. Quickly pause and write before we move. Okay, have you written it? We have next one. We have next one. We have amine. Name of the functional group. We have CONH2, which can be drawn like this. Take note. Take note. We have that. Next one, we have amines. Amines. We have primary amines, we have secondary amines, and we have tertiary amines. We have primary, secondary, and what? Tertiary. We have amines. The name amino, which is what? NH2. We have, this is primary. We have secondary. Secondary. No, I'm sorry. We have primary amine. We have secondary amine. And we have tertiary. That one we have NH. We have N. This one is known as imino. Imino. We have imino. That means this one is what? Amines. This one is primary amine. We have secondary amine, and we have tertiary amine. The name for the functional group of tertiary amine is what? N tertiary atom. N tertiary atom. N tertiary atom. N tertiary atom. Take note. These are what? The functional group and their what? And their structure. We have the amines, which is amino, NH2. We have the what? Primary amine, secondary amine. We have tertiary. I'm sorry, this. I'm sorry, this is primary. I'm sorry, which is primary. This is secondary. And this is, I'm sorry, tertiary. Tertiary. Tertiary amine, which is what? Tertiary N atoms. Take note. Sorry. That's it. This is primary amine. This is secondary, tertiary. Sorry. You can quickly write it. Please quickly write it so that we can move further. We can move further. Please quickly write it so that we can move further. In the next video, we shall look at what? At isomerism. In the next video, we shall look at isomerism. Please, I will advise you for more video, for you to have access to more of our video. Please, on YouTube, subscribe, comment, share. Please press the word subscribe button, comment on this. And we need donation. We need donation for we to produce more of this kind of video. We need donation to produce more of this kind of video. No little money. No money is little. No money is little. We need your support. No money is big, no money is what? Little. We just need your what? Support. The account number will be given on the screen. You can quickly look at the account number. Any amount, no amount is small, no amount is big. Thank you.